Okay, we're looking at quadratic functions and their graphs, and I'm reminding you what vertex form looks like. It makes quadratic so nice and easy to graph. The weird thing is, though, is that our book, for whatever reason, calls this standard form. Usually we think of standard form as ax squared plus bx plus c, and this book doesn't really have a name for that form, but they're calling what I think of as vertex form as standard form. So, a reminder, the number in front of our squaring, it's our reflection. It'll either flip it over the x-axis or not, so it'll either open up or open down. It's also our stretch and compression. H is left-right, K is up-down, which is nice because that's how we can see the vertex. Don't forget to change the sign when you're pulling the number out of the parentheses for H. Now let's look at our first example. So we have a quadratic. It's very easy to tell where our vertex is. It's going to be at 3 and 4. Our y-intercept we're going to calculate just by plugging in a 0 for x. And we get 3 squared, that's 9. Multiply it by 2, that's 18. 18 plus 4 is 22. So our y-intercept. Now let's go graph this thing. All right, so my vertex is at 3, 4. And the problem here is it's not going to model my parent function because it's going to multiply everything by 2. It's a horizontal compression or a vertical stretch, whichever you want to think about it. But if I know that my second point on the parent function is a 1 over and a 1 up, if I multiply that by 2, I'm going to get 2 up. And that will take care of graphing that quadratic. Next problem, and the only reason I'm showing you this is just showing you a reflection. So same idea with the vertex, and same idea with the y-intercept. So I get 2, I square it, I get 4, I throw it negative, and then I add 1 to it, I get a negative 3. So y-intercept is at negative 3, and let's go take a look at this graph. So vertex at negative 2, positive 1. And if this is a exact copy of the parent function, just translated left and up and also flipped over. And the good news is it looks like my y-intercept is definitely at negative 3, so that confirmed. Okay, let's take a look at one that's got a multiplier in front for a, 1/2. All right, so my vertex is at 2, negative 2. The y-intercept, we'll find that when we plug in a 0. Get some room. So I get negative 2 squared, which is 4, divided by 2, I get 2. 2 minus 2 gives me a 0. That's kind of nice. And so my y-intercept is 0, 0, and we're going to figure out the x-intercepts when we graph this thing. So let's go to the graph, graphing a parabola at negative 2, minus 2. Now, I need to calculate, well, I've already calculated at x equals 0, and I know I have a 0 there. So it works out really nice because my y-intercept is also one of my x-intercepts, and the other x-intercept is over there at the negative 4. That. Okay. So lowest first, negative 4, and then 0, 0. All right, I'm going to stop this and see you on the next video.